Hi everyone. In this module, we are going to discuss with some applications of UV visible spectroscopy, IR spectroscopy and mass spectroscopy. The objectives of the units are to calculate the index of hydrogen deficiency, discuss the importance of molecular formula, index of hydrogen deficiency in structural elucidations of an organic compound, list important structural information available from UV visible, IR and mass spectra of a molecule, correlate the signals and their intensities in different types of spectra of a molecule to various structural units present in it, integrate the information available from different types of spectra to elucidate the structure of a molecule. Already we studied the theoretical aspects and the applications of different types of atomic and molecular spectroscopic methods in the previous units. Also, you have learned that molecular spectra contains important information about the structure of the molecule. In this unit, you will learn that how the information available from different types of molecular spectra can be used for the structure elucidation of the organic molecule. In context, we will use information available from UV visible, IR and mass spectroscopy. From this, molecular formula and index of hydrogen deficiency. The information can be obtained by computing a parameter called index of hydrogen deficiency. Simply that is called IHD. It is defined as the number of pairs of hydrogen atoms that must be removed from the corresponding saturated formula to give the molecular formula under consideration. Consider the simple examples like that ethane molecule. In that ethane molecule, C2H2, that is ethane molecule. There are one pair of hydrogen atoms less than that required for the corresponding saturated compound having molecular formula C2H6, hence its index of hydrogen deficiency will be 1. Similarly, we consider ethane molecule C2H2. The number of hydrogen atoms required for the saturated hydrocarbons would be C2H6 minus C2H2, here 4. The number of here 6, here 2. 6 minus 2, here what is that? 4. The number of pairs of hydrogen atoms needed would be 4 by 2, that is equal to 2. What is that? Index of hydrogen deficiency is 2. These are all some examples are mentioned here, some chloropropane. That is also we have to see that formula AC2H6. We find the number of hydrogen atoms are less than the corresponding saturated aliphatic hydrocarbons like propane. Thus, according to definitions, its index of hydrogen deficiency will be 1. Here index of hydrogen deficiency is equal to number of carbon atoms minus number of hydrogen atoms by 2. Here minus of number of halogen atoms by 2 plus number of nitrogen atoms plus 1. You may note that here divalent atoms such as oxygen and sulfur are not taken into account while calculating the index of hydrogen deficiency. Thus, for a compound with the molecular formula as C4H10O, the index of hydrogen deficiency would be 0 as shown below here. 4 minus 10 by 2 plus 1 here 2 1 ja 2 5 ja 2 1 ja 2 5 ja here 5 minus 5 is equal to 0. It implies that the molecule of C4H10O does not contain any unsaturations or a ring structure. The structural information available from different types of structure is a very important thing. Structural information available from different types of spectrum. We consider that mass spectrum. The mass by Z value of the molecular ion plus m gives the molecular mass and can also be used for generating the molecular formula. The relative intensities of m plus 1 peaks can be related to the number and nature of heteroatoms present in a molecule. For example, consider that typical patterns of m plus 1 and m plus 2 peaks is observed if a chlorine or bromine atom is present in the molecule. The odd molecular mass is indicative of the presence of a nitrogen atom in the molecule. However, this has to be further confirmed by other means or by analyzing the fragmentation patterns for the typical nitrogen containing functional groups. The characteristics peak arising from typical fragmentation patterns of various classes of functional groups such as alpha cleavage, loss of small molecules like air, H2O, C2H2, etc. are quite useful. Certain peaks which may be attributed to the rearrangement of the molecular ions or its fragments ions also give significant structural leads. Consider this is commonly lost fragments. This is a fragment lost here CH3. The peak obtained 15. Carbon 12 plus hydrogen 3, 15. OH, oxygen 16 and hydrogen is 1. Atomic mass of oxygen is 16 plus hydrogen is 1. Totally that is 17. Cn. Carbon 12 plus nitrogen is 14. Totally 26. The fragment loss of these molecules like that. OCH3 molecules here. Oxygen 16 plus carbon 12 plus hydrogen 3. Totally 31. In chlorine 35. CH3CO, that is 43. These are all what commonly lost fragments and peak obtained here. Some other elements we mentioned here. Ethane. Ethane means here 28. Ethane is here 29. Here CH3, CH2O, that is what 45. Just we are going to add the atomic masses of elements like that carbon, hydrogen, etc. What are the common stable ions here? The MZ values here 42. The stability of the ions is what? CH3, C triple bond O plus. Here M by Z 91, that is what? Tryptolium cation. Here M by Z is equal to M plus minus 1. Here it is having what? K2. In the case of UV visible spectrum, then absorption in the UV visible region of the spectrum, the UV visible spectrum of a molecule indicates the presence of certain functional groups that have the characteristics N to pi star and pi to pi star transition. These transitions are also characteristics that the Absence of UV visible spectrum for a molecule eliminates the presence of a number of functional groups in the molecule. The lambda maximum and the intensity of the absorption bands are indicative of the extent of conjugation in the molecule. Larger the wavelength, greater the conjugation. In case of IR spectroscopy, infrared spectroscopy, in that IR region starts from 600 to 4000 per centimeter, and the infrared spectrum can be broadly divided into two regions. One is that the region spanning from 3600 to 1200 per centimeter is called the functional group region and includes the stretching vibrations or group frequencies of common functional groups. The absorptions in this region provide information about the presence of characteristics functional groups. The region that includes all frequencies below 1200 are called fingerprint region. This is a very important region. In that fingerprint region includes that molecular vibrations, characteristics of the entire molecule or large fragments of the molecule. This region is useful for confirming the identity of a particular molecule by comparing with spectral absorptions of its authentic sample. In addition to the presence of a particular functional group, the analysis of IR spectrum gives the following information. The presence of hydrogen bonding in the molecule 3200 to 3600 and symmetry in case of alkane, cis and transalkane. This is what alkane. The structure of IR bond here CH3R. IR frequency is 3000 to 2800. The functional group is alkynes molecule. The structure is here RC triple bond CR 2000 to 260 to 2100. That is the spectral range. In that alcohol OH is a functional group ROH. Here 3600 to 3200. That is a broadband. The nitrate is a C triple bond can. We consider the structure of this nitrile is this thing, that absorption. For amides molecule or amines molecule, what is that? 3500 to 3300. For this alkanes molecule, here 1600 to 1680. Carboxylic acid RCOOH, the functional group is in that 3200 to 2500. That is a broadband. We consider for this benzene ring. Benzene ring is carbon-carbon ring. For that breathing here, what? 1450 to 1600. These are all the representations of these aldehydes. It appears in 1750. For alcohols or ethers appears at 1300 to 1000. Carboxylic acid here 1790 to 1680. Alkyne 3300. Amide molecule is in that 1850 to 1800 and 1790 to 1730. In acid chloride here 1815 to 1790. In acid anhydride, here is acid anhydride. In acid anhydride is always 1850 to 1800 and 1790 to 1740. For this nitro compound is in that here 1660 to 1500. That is a symmetric stretch. In that symmetric stretch here it is having 1390 to 1260. In addition to the following features of the proton or nuclear magnetic resonance and the structural informations available from them, the spectral data tells us about the following important aspect of a molecule. The number of different signals in the proton NMR spectrum indicates about the different types of proton present in the molecule. The position of the signals, their chemical shift values tells about the electronic environment of a particular proton. The chemical shift of different types of protons are given below. These are all different types of protons with respect to different functions. The area under the peaks obtained from integral for signals of various types of photons provides information about the ratio of the number of different types of protons present in a molecule. Here, the spin-spin splitting patterns of a particular signals gives information about the number of neighboring protons present around the given type of protons. Structural elucidation of molecules. That the structural elucidations of organic molecules. In this section, we will discuss the structural elucidation by taking some organic compound as example. We will analyze the data available from various types of spectra for a given compound and integrate the information about various structural units present in the compound to arrive at its structure. We consider examples. Here, the molecular formula is C3H6. Show that the following spectra reduce its structures. Here, how it is, like that it is coming. Okay. Solution. Here, there is no unique way of solving a problem of structure elucidation. What we need to do is to pick up all the important information available from the spectra and then integrate them to arrive at the structure. Sometimes one or two spectra give enough clues to the structure. In such cases, we suggest a tentative structure and check that whether it supports the other data. Let us making IHD is equal to number of carbon atoms minus number of hydrogen atoms by 2 minus number of carbon atoms 2 plus number of nitrogen atoms by 2 plus 1. IHD is equal to 3 minus 6 by 2 is equal to 0. The IHD of 0 clearly shows that molecule does not have any unsaturation or a ring structure. This is very important. Just you very important question. The IHD 0 clearly shows that molecule does not have any unsaturation or a ring structure. The IR absorption bond around 1700 per centimeter is indicative of carbonyl group. This may account for oxygen in the molecule. But in case of NMR spectrum provides two important bits of information as given below. The single signals indicates that only one type of proton is present in the molecule. All the protons are equivalent. Then the chemical shift of delta is equal to 2.2 indicates that the protons are slightly deshielded, maybe due to being the neighborhood of an anisotropic in nature. The mass spectrum shows prominent peaks at m bar z is equal to here 15, 43 and 58. The m plus ions appears at m by z 58 while the basic peak is at m by z 43. The m plus peak is in accordance with the molecular formula and the base peak m minus 15 is inductive of a stable COCH3 plus ions, which is obtained by the loss of CH3 radical from the molecular ion. We consider some other examples like that. Molecular formula is C7H8. This shows the following spectra. From a given spectra, we will now see what could be its possible structure. These are all very important examples. Important examples. So, ನಿಮ್ಮ theory ಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ, ಎಕ್ಸಾಮ್ಗೆ ಬರುವಂತ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. This is called what? The structure of this C7H8. This C7H8, this is wavelength versus intensity. This is what percent of transmittance. This is what percent of transmittance. Here, what is that? IHD, intensity hydrogen deficiency. Let us again start with molecular formula and calculate its IHD. We get, this is the formula. Here 7 carbon atoms, number of hydrogen atoms is 8 by 2 plus 1. Totally what we are getting here? 43. The IHD of 4 suggests that compounds does contain a ring or a molecule. In that NMR spectrum is quite useful in this case and provides the following information. What they are going to providing? There are two types of protons. The integrations of the peaks shows that the number of the two peaks of protons is in the ratio of 5:3. The signals at delta 7.2 indicates the presence of benzene ring. And the other signals for 3 protons at delta 2.2 can be attributed to a CH3 group attached to the benzene ring. The presence of benzene ring accounts for IHD of 4. There are very important pieces of information available from the IR spectrum. The bands in the region 1400 to 1600 per centimeter point to the presence of a benzene ring. The signals at 1005 per centimeter is quite characteristics of the same. Two strong peaks near 690 per centimeter and 750 per centimeter indicates mono-substituted benzene ring. These are due to out of planning beaching. This one. Next, we consider the signals at around 1050 per centimeter can be ascribed to sp2 carbon hydrogen stretching, while at about 2900 per centimeter is due to sp3 hybridization CH stretching. Thus, the IR spectrum clearly points to the mono-substituted benzene. In that, mass spectrum shows that M plus peak M by Z 92 and the base peak M by Z 91. Looking at the table, we can say that this peak could be due to benzyl carbocation as shown in the following structure. Here, what are those following structure? Here, tropelium. This is the example of this molecular formula C7H6. Exhibit the following spectra. This is what? Intensity. This is what? Transmittance. What is the solutions? To arrive at its structure, we start with the determinations of IHD forms its molecular formula. We get IHD is equal to 7 minus 6 by 2 plus 1, finally 5. Again there may be possibility that the ring or the double or triple bonds may be present in the structure of the molecule. We consider IR spectroscopy. Similar to previous compounds, the IR spectrum suggests for a mono-substituted benzene. Here the aromatic carbon-carbon double bond stretch is observed between 1600 to 1450 per centimeter. Two strong peaks near 690 per centimeter and 750 per centimeter are indicative of out of the plane. Double bond CH bending for mono-substituted benzene. In addition, the strong signals at 1700 per centimeter suggest for the carbonyl group. In addition to the strong signals at 1700 per centimeter suggest for the carbonyl group. The double bond between 2850 per centimeter and 2000 750 per centimeter is characteristics of CH stretch of aldehydes. This chapter qualifies the nature of carbonyl groups, thus an inductive hydrogen deficiency of 4 out of 5 is accounted for by the presence of benzene ring and the 5th by the carbonyl group. Thus, we may see here that the IR spectrum has provided enough leads to suggest a plausible structure. In this molecule, an aldehyde CHO and linked to the monosubstituted benzene ring ends the compound as structure C6H5CHO. Next, in that NMR spectrum also supports that proposed structure. Let us consider available fluorescence. Let us see that available information. The multiplet between the chemical shift value 7.4 to 7.9 is successive of aromatic protons. The one proton signals at 298 is quite useful as it is suggestive of an aldehydic protection. Proton. The complex multiplied between delta 7.4 to 7.9 when resolved under high resolution show that there are 3 different types of aromatic protons and these are in the ratio 2:1:2. The multiplet when observed at near resolutions that shows a doublet or to triplet. The doublet at delta is equal to 7.5. It is due to 2 ortho position. It is due to 2 ortho position. The triple bond to 1H at chemical shift 7.6 is due to teraproton and the other triplet is due to 2 metaprotons appears at about chemical shift 7.9. Thus, the proton spectra, NMR spectra data also support that the compound is benzaldehyde. This is what mass spectroscopy. The mass spectrum also supports the suggested structures. Let us analyze the evidence. The molecular ion gives an intensity here M plus and M plus 2 and equally intense M-1P at M by Z is suggestive of the loss of one hydrogen atoms via the alpha cleavage process. Alpha cleavage process a very favorable fragmentation mechanism. Okay, this is all the element in that benzaldehyde. That benzaldehyde, the compound D having molecular formula C3H6O. Show the following spectra data found that. Here this intensity ratio, this is mass by charge ratio. Here in that transmittance graph of that previous one. Finally, solutions. What is that? The solution of this. We can compute the IHD for the molecule to be 1, suggesting a single double bond or a ring. IR means the IR spectrum of this molecule show a feature that we have not observed so far. Let us see what informations do we get from IR. In that IR we are getting here 1700. It is a characteristics of the carbonyl group and 3000 per centimeter. It is what? Characteristics of OH stretching probability hydrogen. In these two pieces of information indicates towards the presence of a benzene ring functional group, COOH functional group. Let us see other spectra of multiple different types of protons. There is small highly downfield would is likely to be due to acidic protons of the COOH. The typical patterns of two protons quartets. Typical patterns of two protons is quartet and three proton triplet at about here 1.2, 2.8 chemical shift respectively are suggested of CH2, CH3 group. On the basis of spectra, the tentative structures of the molecule can be proposed to be CH3, CH2, COOH. Thus, let us check whether the same mass spectrum supported or not. The mass spectrum containing the following information. The molecular formula of MH plus, M plus and M by Z is equal to 74. AM17P at MZ57 was indicating the loss of OH. The intense peak at M by Z29 would be due to loss of proton. This is what some other example they mentioned here. What is that? C5H9O2 exhibits the following spectra suggested 8. Here this is what? Observe intensity for graph and transmittance graph here. What is the useful of first calculate the IHD from the normal formula? Here IHD is equal to 5 minus 9 by 2 plus 1 plus 1. Here what is that? 1 only. So the molecule has a double bond or a ring. Let us see that what spectra suggested. IR or initially IR spectrum given below. The strong bond in the region 1750 to 1735 centimeter indicates CO stretch. This along with two strong stretching absorption in the range 1300 to 1000 per centimeter due to carbon oxygen indicate in the presence of esters formation. In that NMR, the proton NMR spectrum shows the presence of 4 different types of protons. The quartet here, the chemical shift delta is equal to 4.23 and delta is equal to 4.29 or 4 protons of protons respectively. The other two signals a doublet. Delta is equal to 1.68 and triplet 1.31 or for 2 types. One triplet and one quartet would be attributed to ethyl group. There, other quartet and a doublet may due to CH2CH Cl unit. This is what benzene. Let us see how does the mass spectrum is helped us. The interpretations of the mass spectra is given. The M plus peak at M by Z 136 is very small. The base peak M by Z is equal to 29. The suggest the presence of this what C2H6. This is what 91 that is presented that here C2 OC2H3 etc. Yet the reasonably intense peak at M by Z is equal to 63. Thus go into support the proposed structures as this may correlate to C3, CH3, CH, Cl. Moiety which may be obtained from the loss of CO from and M by Z 91 peak of CH3, CH, CO, Cl. This is all example 6. Yes, we go through that. These are all different molecules they are going to introduce here. Glutamine and cyanoacetamide. Ethyl benzoate, this is what the aspirin molecule, that aspirin molecule which contains here OH is there, CO is there. You go through that. This is a cyclohexanes molecule, mass and IR spectra of cyclohexanes molecule. This is mass spectrum, this is IR molecule. This is mass spectra of 3-pentane 3-ONE. This is a mass spectra of pentane 3-ONE. And this is IR spectra, mass spectra of benzyl acetate. This is what benzyl acetate, this is what transmittance of this ethyl benzoate. This is IR spectra of this phenyl acetate in mass and IR spectra of allyl acetate. Allyl molecules means alternative single and double bond. Now we are going to conclude the unit of this. The determinations of molecular formula is an important aspect in the structure elucidation of an organic compound. From the molecular formula, the index of hydrogen deficiency can be calculated. The knowledge of IHD helps to know about the possibilities of presence of unsaturation and or rings in a molecule. The different kind of information is available from various spectra of a molecule. The mass spectra data helps us to know the molecular mass of a computed and the fragment ion of a molecule. An analysis of the fragment ion space indicates the type of functional groups or structural units that may be present in the molecule. The IR spectral data indicates about the extent of conjugation present in a compound. The IR spectra data tells about different types of functional groups present in a compound. It also gives information about the presence or absence of hydrogen bonding and substituent patterns of aromatic. Okay. These are all important. The things just you go through that to calculate, and please consider some working examples and exercise questions, everything. Okay, these are all very important in the point of your theory examination. What examples we are going to discuss here? What is that allyl acetate, both mass and IR spectroscopy, and we consider phenyl acetate, mass and IR spectroscopy of phenyl acetate, benzyl ester, acetic acid, and pentane 3-ONE. Okay, these are all the cyclohexanone. These are all very important in the point of theory examinations. Okay, thank you.